This is lecture number 14, which is for peer-to-peer mode, and in today's lecture we will be covering multi-layer DHT. So why we call it multi-layer DHT is because single DHT network is not good enough sometimes for when you are running many services. So as far as only searching for a key value pair and storing only one kind of key value pairs across the whole network, then single DHT network is good enough. But in any real life implementation, you probably have to go for multiple layers. So first thing is, what will be these layers will look like. So what do you mean by layers actually? So one thing which is important is that every node which is participating may not be participating in DHT. So if it is not participating, it will be a leaf node. So if it is a leaf node, it may not even require a node ID, because nobody will be communicating via DHT network to it, and it will be most likely there is no node ID for leaf thing. It will be going to have an user ID by which if somebody wants to communicate, can communicate to them actually. So this will not be participating in DHT. That's also clear. And this user ID can be accessed, or this node can be reached only via the endpoint address. So this endpoint address somehow should become discoverable based on user ID. So these will be one kind of nodes. I am only talking about the first, the base layer part. There will be some nodes which we call them core nodes. They will be participating in DHT. They will also have node ID attached to them. So remember, the node ID, as we have discussed in earlier lecture, consists of two parts. So one is basically being generated using public private key pair generation, RSA algorithm, and the public key part is what is your node ID. This is this, and whenever this is being presented, I need to always digitally sign it with a private key. So I can actually, when I am signing, I have to, this is a signed hash which is going to be added, and I can represent this thing as hash which is signed by private key. So this is what is going to be always will be available. Reason for doing this is that we will ensure that public key is always generated as a random number, because both have to be generated together. You cannot arbitrarily choose a public key. So if you decide on public key first, then want to generate private key, that is not feasible. So core node will do this. Core node will also have endpoint address, there is no doubt, but this endpoint address can be identified by sending a query directly to the core node. So this never need to be kept in the database. Now I will define the base layer, where in the base layer all the node IDs which are participating in the DHT. So these nodes which are core nodes will be the part of base layer. So these nodes will be now only storing either user ID to node ID mapping, or they will be actually storing user ID to endpoint address mapping. So these two things can only be kept, nothing else. Okay. So when these entries are kept, now the problem is a user can go off, and after some time a new user comes in, he by chance chooses the same node ID, then this entry has to be purged. This entry only has to be there till the user is there for some time. If user actually is down or user churn is there, in that case we have to retain for some period. So normally the algorithm will be that if every user, so he will be having a user ID, he will be refreshing this entry, he will be republishing in the DHT. Once it is done, there has to be a timer which need to be associated. This timer will be reset. So this timer will be reset whenever this refresh or republishing will be happening. This will be reset. If this timer expires, this timer normally will be very large. Then of course this node does not exist, that's what we assume, but we can retain this entry still for some time, so that if user comes in, then actually he can just do the refresh. Of course I will not be using this entry for doing anything as of now, okay, but some other users can actually identify if that user, so what is the node ID for that if they want to have. So there will be another timer which will actually cause a purge timer for this. So whenever the reset this particular timer expires, then purge timer will be kept, and after purge timer is gone, this entry will be removed from the table. So similarly, there will be also a timer here which have to be maintained, and there has to be a purge timer. So this is very similar, very standard technique of having two timers. This is also used in distance vector routing protocol for removing the obsolete entries. Same thing is also done in OSPF also. So more or less wherever the entries have to be refreshed, we actually first of all disable it, and after some time only we will actually remove it. So the same procedure we are also following in our Brihaspati 4 design also. So every user need to keep on refreshing this particular entry. So the refreshing is very important, and there is a timer. Okay. So now coming to what will be the other layers, and then how we will organize. So this is not good enough. This is for a voice over IP kind of thing. This may be okay. So from user ID, I will find out a node ID, and if that node is participating in DHT, I can actually make a query for that node and node ID, and that essentially query will terminate at the same node itself, because that's the user has published its own node ID. Okay, and then based on that, then I can directly talk to him. Once I know, that node ID will tell the IP address back, endpoint address back, and then you can communicate. If that guy is a leaf node, he will be actually publishing in the DHT network his user ID to endpoint address mapping. So when I want to talk to him, I will search in the DHT for this user ID. This time I will not get node ID, but I will get endpoint address. And then I can directly communicate to him and then do the voice communication with the other endpoint. Okay. So now what will be the other kind of DHT? So one of the very important thing is a voice over IP is a service which is normally does not require a separate DHT. Okay. This will be based on purely on this base layer. Then we can have storage. So idea here is that a lot of people actually have extra storage space, so you can communicate, you can donate it to the community. So everybody does it, so I actually get a large pool. So whenever you want to put your files, you will put your files, you can actually fragment them, and then these fragments based on their some key identifier. We will talk about this storage design later. Based on that, these fragments will be distributed across the network. So even if your machine conks off, it dies, you can put another machine, set up everything, and then you will be able to access your system. And we have to have a built-in resilience or reliability mechanism for this DHT layer. So we'll talk about this reliability later. So storage can be a layer, but now the way in base layer, every node will be participating, but except some nodes which are the leaf nodes, they may not be participating. So I have a base layer thing. So the nodes which are participating in DHT are in this set. There will be some nodes which are outside. So these becomes a leaf node, so which will be using endpoint address. So they may be having the node IDs and they can communicate, but nobody can communicate to them directly because they don't maintain node ID. They need not at the base layer. Now further taking up the concept, out of this some nodes may decide that I am only going to do, these nodes only participate in providing the storage space. So I will create their separate DHT for a storage providers. Okay. They will form a separate DHT. Now what will happen to these other nodes? They are not providing storage, but they need to use the storage. So they will become now the leaf node for, so this particular part, whatever is there, will become the leaf node for the storage DHT. So in the same base layer, I can actually have even other services. So I can now provide, for example, sandbox virtual machine. So you can actually push in the compute job. So these machines are, so I have to draw a separate, this is the base DHT. So some machines will be providing the sandbox VM service. Okay. So other guys will only simply be using the service provided by these. So even if one of few nodes dies, the load essentially gets disbalanced depending on for which node who is going to be responsible in this. That's what we will do through essentially mapping. Okay. We can have similarly intermediary services. Now this service, there is nothing like a storage. Okay. There is no reliability which is required. If a node dies off, I will just get something else. This is a storage. Here your files are going to be stored. So the fragments of your files will be stored across the whole network. So there need to be reliability. So there is going to be a separate resilience mechanism which need to be built in this case. In this case, you will not be requiring it. So we can also have intermediary service, for example, messaging. So if the other endpoint, the destination is off, so where his message need to be deposited. So there can be again in the same base layer DHT, some nodes will decide we will be acting like a message storage. But message are not going to be stored forever. So there normally you will be, each node will be passing on the message if the other person is active at that point of time directly. If it is not there, then this message storage will be used. Okay, so we call it a message storage. We can have similarly another layer, for example, say audio mixer. So you are doing video conferencing. So there will be again a problem that normally everybody's audio should not come to you and then you are not locally going to mix, because then your bandwidth will be consumed. If there are 50 guys transmitting audio video and you get all 50 audio videos, that's very cumbersome. So normally it's a good idea that all audio videos can go to some nodes depending on whatever is the capacity. So 10 guys can connect to one. He will generate a audio video. There is another guy which actually gets this thing. Okay, it also mixes it. These two actually then mixed audio videos are sent to third guy which will do the final mixing, and this get broadcasted to everybody. So these are mixer nodes. Okay, so we can actually define say mixer at mixer 1. So this is layer 2 1. So I can define similarly an ID for this mixer layer 2. This is mixer at layer 1. And then of course I need to append what is going to be your stream which you are talking, the conference ID which you are talking about. Okay, so in voice over IP this can be added. Now who will become the mixer? Not everybody here. So there will be some nodes you may say willing that I am going to become a mixer. So there is going to be a mixer DHT in that case which has to be there. So they will act as a bridge, conference bridge. So everybody can communicate to them, they will mix and then it is going to be broadcasted. Okay, how this body of broadcasting will be done, I will again tell in one of the next lectures. Okay, so we can have this AV mixers, I should call it say AV mixers, okay, which will be acting as a bridge, or I can also call them bridge, and they can form a DHT. Now the moment you form such a DHT, what has to be done? There is a problem here now. How the routing tables will be managed. So one thing which we understand that in some layer you are a leaf node, in some layer you are a core node, and also now remember we are implementing in Brihaspati 4 an optimization because we are using tapestry algorithm. In fact, tapestry and we have combined the chord thing. So to reduce the number of nodes in a column, so we only use predecessor, successor and middle value, and based on that we do the routing at 1 digit level. Okay, and we are using a hexadecimal number. So we are also now going to maintain neighbor tables. Neighbor tables are based on proximity. So maybe round trip time will be used here. That's what we are planning as of now. So this takes care of, because you are sending a message that is coming back, it's actually taking care of the network load on both sides, and based on that it is figuring out who is closest to you. So it becomes a more efficient, or basically time wise, in least time all this communication will be happening in our DHT system in Brihaspati 4. So there will be neighbor tables also, and there will be these routing tables. So what happens is, for each layer, so there is going to be a layer. I will be having a routing table for this layer. I will also be having a neighbor table for this layer. So routing table and neighbor table for each layer will be maintained. Now there will be nodes which are leaf nodes for this layer. They are just using the service. So they will also be maintaining a routing table for that layer. They will also be maintaining a neighbor table for that layer. But these leaf nodes, okay, this is for the core nodes. This is for leaf nodes. But these leaf nodes cannot be used as a transit. So nobody else need to keep this entry of this leaf node in their neighbor table for that layer, as well as in the routing table for that layer. So leaf nodes will periodically, so there is going to be again a timer associated with periodically will send only heartbeat, that they are alive, nothing more than that they are alive. And they will mostly will be, once the heartbeat is sent, that technically to all the guys who are there in the routing table, who are all the people who are in the neighbor table. So whenever heartbeat is received, whenever the heartbeat is received, the local routing tables, now this heartbeat now has to be, we have to identify which layer. Okay, so for different layer, essentially now it will be different heartbeats. You may be sending at the base layer to everybody, but at a higher layer only to some people. So the other guy has to identify which routing table or which neighbor table has to be sent back. So this heartbeat also now will contain, now this is a change which is going to come, layer ID, okay, or whatever DHT which I am going to define. So even all routing tables will also have a layer ID which is required. So we can define multiple layer ID for different purposes. So when heartbeat is received, layer ID will be identified. So what you will be receiving this as well as a layer ID. So RT for that layer. Okay. So for this particular layer, which is for which heartbeat has come, copy of RT for that layer and neighbor table for that layer, okay, will be sent back, will be sent. Okay, so whoever the source of heartbeat, will send it to that. So now remember this, this heartbeat is being sent to whom? Sent to everybody who is there in your, so this I am talking about the leaf node as of now first. Okay, this is for the leaf node. So all members who are present, this we are sending this particular heartbeat to them. Okay, so I will be getting lot of nodes, so I will update my local neighbor table. Okay, so the leaf node, for that layer, the neighbor table which is there, that will be updated, and you can also update the routing table for that layer. So for all layers this has to be done. So if there are very few nodes, I think very few routing table entries which will be there. Okay, and that you will be keeping. Okay, now the routing table essentially depends on what is your node ID. When you are a leaf node in a layer, then it is okay because you have a node ID and then you have to keep it. But if the leaf nodes, for example, I have told that leaf node in the base layer may choose not to have a node ID because they don't require this node ID. If they choose to keep it, it's going to be there, but it cannot be used for routing. So this entry should not exist in any routing table. Okay. So routing table will always be present. Okay. So this routing table optimization basically depends on what is the current node ID. So the leaf nodes which don't actually have the node ID, how they will maintain this the routing table. This becomes a challenge. So this basically depends on RTT, whatever is there for every layer, it can keep on making the neighbor tables. But what about the routing layer? They have to assume some node ID in that case. In fact, either they don't require, if they maintain node ID, they should maintain routing table. If they don't, they actually should simply assume a node ID which is by one of their neighbors. Okay, so essentially, if this leaf node will only be maintaining this routing table if it is at the base layer, if there is no node ID assigned to it. In that case, it will not be requiring a routing table, it has to just hand over to somebody. So it will just use one of the neighbor table entries to forward the query, and from there the query can further move. It only need to maintain this routing table, actually will not be required if you are a leaf node without node ID. If you are leaf node with a node ID, then you are going to maintain a routing table. Advantage of maintaining a routing table is only maintaining neighbor table there is a problem, because if you are, for example, in IIT Kanpur campus, I have maintained only my neighbors, and suddenly somehow what happens, the network is dead. Okay, and I am able to connect through some other network, but my only gateway was this. I have to again start this whole neighbor table is waste for me now. Okay, I have no other entry. I have to again start connecting to a bootstrap node, and from there get a routing table, and then find out then optimal entry for me. Okay, again do a neighbor table search if I connect even through another network. So it's actually always good to maintain a node ID, because that way you will never be getting isolated from the network, because you will have in the whole node ID space from every partition you will be maintaining at least one representative. So even if you are connecting to another network, from there you can start populating the things back. So now for each layer separately the routing table exchanges will take place, and for each layer we will also be having routing table. So this is for the leaf node, that they actually should preferably have a node ID, and correspondingly they should also maintain now neighbor tables as well as a routing table for all layers. Now the nodes which are in the core, what they will do. So let's come to that. The nodes, if you are a core node, in that case you will not be sending heartbeats, but you will be actually sending your neighbor table. So for each layer where you are actually there, if you are in a layer, if you are a leaf node, then you will be sending heartbeat along with the layer ID in the layers in which for which you are actually updating your local tables. But if you are participating in a layer, you will be now broadcasting your neighbor table as well as your routing table at that layer to all the entries which are actually there listed in these two. Similarly, from the other side, you will be also getting from when you are sending your routing table and neighbor tables to all the entries maintained here, you will also be now requesting from all these people to send their neighbor table and routing table. So in fact that you don't need to do explicitly. The rule is you will also be getting a request from others. So other people will also be sending to the neighbor table for a certain layer. So remember, when this information is sent, the layer ID need to be sent in all such messages. So it's a layer by layer communication. So when you receive a neighbor table as well as routing table along with the layer ID, so you will use this two things to further optimize your neighbor table as well as routing table both, as well as whoever has sent this entry, you will also consider that as also that node ID also as a potential candidate to be used in neighbor table as well as routing table both. Okay, while in case of when a heartbeat is received, that source node is never considered. Here source node ID also need to be considered for this purpose. That will be one difference which will be happening. Okay, and so you will be sending your tables to everybody who is listed here. So your source ID as well as all the entries which you have will be considered by the others for their optimization, and you will be doing it whatever you are getting from other people. So their source node ID and whatever they are sending, and for at every layer you will be doing this optimization. Sometimes now either one optimization which can actually be done at this case we have not thought about it. We as of now are planning to send for each layer separately the neighbor table and routing table both. But for certain entries, for example, are common to multiple layers. So same entry exists in one particular layer 1, layer 2, layer 3. So I can actually now combine these and basically compress. So we can additionally put a compression of data. Okay. So but this also is slightly tricky because you need not send everybody the routing table for all the layers, because you may not be participating on the layers. So when you are leaf node, you don't send any routing table for that layer, you only receive it, you only send the heartbeat packets. Okay, so compression probably does not make sense. It will be much more cumbersome because you have to figure out which all layers has to go to which particular node ID. And if you know that for all those node IDs, all those layer IDs only, you will be compressing. If they are common entries, you will be, instead of multiple, make only one common entry. That's what you can do. So technically, if this is for layer 1, this is for layer 2, you have an entry here, same entry comes here. Okay, so instead of repeating this entry twice by sending these tables separately, and they both have to go to same node. So this node is also now layer 1 and layer 2 subscription. So I will be now compressing and will only send it once, but while mentioning it that this has to be in layer 1 as well as in layer 2. So that's a kind of optimization which can be done, but this is independent of the DHT algorithm which we are talking about. So layering is very important, and this need to be implemented so that various different kind of services can be done, implemented in the whole system. The only thing is that the base layer everybody has to participate, and if you are a leaf node, you don't want to store anything. That's the only way you can become a leaf node. But since if you carefully observe, when I am talking about this, I am talking about a user ID. So one device will have one user ID. So if a user is going to have 6 devices, so user ID will map to only one particular root node. So that root node will maintain only 6 possible entries, 6 node IDs here. But all these devices also have node IDs. They will also be maintaining on an average only whichever actually is, they will become root for some of the people and they will be maintaining. So on an average, there will be only one entry which will be maintained for each node, which are the core nodes. And of course, the leaf nodes will be now spread around. Their user ID to endpoint addresses will be maintained. So their node IDs will not be there. So their user ID to endpoint address, but they will not be maintaining any entry on their own. So on an average, it still remains one entry per each node ID. And I am assuming now that for even for leaf node, we will be maintaining node IDs. Okay, they will have node IDs, but this will not be used. Okay, so that way, but the problem with this kind of system is that other people will be able to figure out that can also reuse this particular node ID. That's the only problem. If it's in the hash, then there should not be an issue. So ideally speaking, everybody should participate in the core node, and then of course should participate in the base layer DHT. Okay, so finally, in case if you are actually using the leaf node, if it's going to use node ID, then it actually can maintain routing table in an optimum way. Otherwise, it actually need not maintain. And normally node ID, if it is maintained, the problem is a duplication can happen. And for avoiding this, this has to participate in a base layer DHT. Okay. So at least base layer, because any new node ID, any new node which joins and which when actually searching for whether duplication of the whatever new node ID which it has generated, it has to search in the base layer. And base layer, since everybody is participating, duplicates can be avoided. In case if it is a leaf node, even in base layer, then let node ID not be there. So the best strategy is that, because there is no use of maintaining routing table, only best what it can do is it can get routing tables from whatever entries are there, and based on that, based on only on neighbor table, it can actually do the updation and optimize it. Okay, it cannot do anything because it does not have any node ID. So it cannot find out what should be the routing table. So it has to essentially some other node ID which is participating in DHT as a proxy. So essentially it will copy the same routing table there. So it need not even seek from everybody. So one alternative is it can directly contact that guy, fetch that same routing table and use that for forwarding it further. And every time keep on periodically doing it. If this guy dies off, it can fetch the routing table from somebody else. And ideally it should fetch from somebody who is closest to it based on the neighbor table. Okay, so that the minimum network load is going to be there when leaf nodes are searching. So with that, we actually end our discussion on this multi-layer DHT, and next we will be looking into how we will actually do resilience in the key value pairs which are stored in a DHT layer. So how that actually gets implemented. So that will be the topic of our next lecture.